Okay, dan nakatali na rangwani. Good morning. I know that it's been a long time that I have been um, silent 1 week. Last week, I was working Dutch kumunta takarunay no the lessons 12, 13, and 14 exercises and put it through my inbox. I haven't received anything from anyone. Okay, so we are continuing lesson 15. Now, I want to take a look in an avuli. Let me remind you that I will not go through these lessons again. I will continue the coverage. So, if you want to go through these lessons, you will have to go through the lesson notes that I put on your page and the videos that goes with it. So now we are up to lesson 15. Okay, you should count yourself blessed because there are some schools that haven't reached this stage, but you have reached this stage. Okay, and there are a few more lessons to go, and then we'll be done with the coverage. Not few, but about 10 or so. So that means you have to stay in touch with this kind of learning. Okay, so today we are learning sequences. So in sequences, it's an order of list of numbers that you can see the series in your notes. Okay. This is called a sequence. This is called a partial sum. A partial sum. Term 1 is S1. Term 2 is S2. Sum 2 is term 2 plus term 1. Okay. Sum of first three terms is term 1 plus term 2 plus term 3. So this is called series. When you add the terms, it's called series. When you list the terms, it's called, using a pattern, it's called sequence. Okay, like in form 6. So if you go up, it says converge and diverge. The sequence will approach a definite value. That means it will approach a number, whether it's 0, negative, or positive. You are to say that the sequence converges. If the sequence converges, we call the value, it approaches the limit. It approaches a y value. That means it converges. If the sequence has a limit, we say the sequence is convergent and that the sequence converges to the limit. Otherwise, the sequence is divergent. Kaya sinindo na kaya na value, kaya balako sini converge, kaya diverge. So this is the meaning of converge and diverge. So and this is in the example I'll show you how to do this. Okay, now let's go up. Example 1. This is from the textbook. Tn is equal to 2 to n. Can you see? No, you can't see. Let me get ready to the bit so you can see. And move it a bit aside. And you're good. Tn is equal to 2n. Okay. Part A says find the first 4 terms of the sequence. So that means term 1, term 2, term 3, term 4. Tn, n is the number that is hanging. So everywhere you see n on the formula, you replace the value of n. So here it's 1. So 1, 2, 3, 4. The formula here, the expressions is defined, the sequence is defined as 2n. So 2 times 1, 2 times 2, 2 times 3, 2 times 4. Different sequences have different definitions. So this will change as you go along. Okay, so your answer for T1 is 2, T2 4, T2 6, T4 8, and this is how you write it as a sequence. Okay, now as a partial sum, this is right as partial sum. As a partial sum, the sequence of the partial sum, that means you're going to add. Now T1 is equivalent to S1. T1 is equivalent to S1. So 2, 2. S2 is equivalent to T1 plus T2. T1 plus T2. So that becomes 6. Sum 3 is equivalent to T1, T2, T3. T1, T2, T3, that gives you 12. Okay? Sum 4 is equivalent to T1, T2, T3, T4. T1, T2, T3, T4. You add all that, gives you 20. So this is called the partial sum. It's also written as sequence. This is how you write down your sequence in the exam. Okay? Sequence is, it has a bracket that looks like a less than and a greater than sign. And then dot dot dot, because this sequence will continue. And also partial sum is written as a list. Don't forget this as your final answers at the bottom of your calculations when you are calculating the terms of the sequence and the partial sum. If it says term 1 to term 5, do term 1 to term 5. If it says term 5 to term 8, do term 1 to term 8. Term 5 to term 8. Okay? So, remember, these numbers hanging here, these numbers hanging here, these numbers, they are called TM. Do not take this number in this working and replace it back here. The answer may na sequence ko kolo takeke. Because na bangara kinanong sum. Sum means add. Add. S1, T1. S2, T1, T2. S3, T1, T2, T3. S4, T1, T2, T3, T4. Okay, I hope that is clear. Now we'll move to the next example. Okay, this is our next example. The sequence 7n is defined as an equals 7n plus 3 over n minus 9. Your question are find the first 4 terms of the sequence, find the first 3 terms of the sequence of partial sum. That means you're going to add and then find the limit. I'll show you how to do this. This is done in limits and continuity, this one, and then explain why the sequence converges. Okay, so we'll do this now. Let me switch my thing around so you can see. Okay, so that's our sequence. So we're going to do part A. This is our expression. Part A says first four sequence. So T1 is equal to S1 plus 3. See what I'm doing? I'm replacing 1 instead of n. Okay, so that's 10 over negative 8. So that's T1. I'm going to move down. Okay, then you have T2. T2 says 7 times 2 plus 3 over 2 minus 9. So that's equivalent to 14 plus 3 is 17 over negative 7. Okay, T3 is 17 over negative 7. Used to calculating downwards. Okay, so I'll put T3 here. T3 is equivalent to 7 times 3 plus 3 over 3 minus 9. 7 times 3 is 21. 21 plus 3 is 24. 24 over negative 6. It says first 4 terms, so I'm going to do the first 4 terms. Okay, T4 is equal to 7 times 4 plus 3 over 4 minus 9. 7 times 4 is 28, plus 3 is 31, 31 over negative 5. Okay, so your AN sequence, your AN becomes 10 over negative 8. Is that going to write it? 17 over negative 7, 24 over negative 6, and 31 over negative 5. Okay, and then dot, dot, dot. Yeah. Okay, this is your sequence. This is your sequence down here. Okay, first 4 terms. Okay, and then it says partial sum. Okay, I'm going to go up back here. That's the sequence. Okay, and then this is partial sum. So I'm going to go back up here. I'm going to start from S1. S1 is A1, or T1, so that's 10 over negative 8. S2 is equal to 10 over negative 8 plus 17 over negative 7. S3 is equal to 10 over negative 8 plus 17 over negative 7 plus 24 over negative 6. So all you have to do is you can use the calculator to calculate this. This will be the answer for S1. You can use the calculator to calculate this. I don't have the calculator by my side. So you can use it and then you list it at the bottom. And this is equivalent to whatever here. Then S4 is equal to 10 over negative 8 plus 17 over negative 7 plus 24 over 17 over negative 7 plus 24 over negative 6 plus 31 over negative 5 gives you what? Okay, now when you're done, I want you to list your sequence as well. 10 over negative 8, then the next one, then the next one, then the next one, dot, 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 cross. Okay, these 3 answers from here will come down here. Okay, so I'll leave you with that. That's for Gona partial sum. Okay, partial sum. This is the first 4 terms. Okay, so now we'll move to the next part. The next part says find the limit. Okay, so that's part C. This is A, this is B. That's part A. Part B is partial sum. Okay, part C is limits. Limit x approaches infinity. I'm sorry. In this case it's n, because you're going to take it from n instead of x. And you have 7n plus 3 over n minus 9. Okay, go back to your rule for limits. If it approaches infinity, your rule is simplify highest power. Simplify highest power. Okay, or the blocking method. So, equal limit n approaches infinity. I'm going to ignore this. Ignore the numbers. So 7n over n. Okay, and now I'm going to simplify the n. Limit n approaches infinity. If you simplify n, you'll get 7. Okay, the rule is if limit n approaches infinity constant, your answer is always a constant. Okay, that's the rule of limits. Okay? One rule is when you simplify, when you approach infinity, you simplify the highest power, especially for this for sequences is always infinity, so you simplify the highest power. And if a limit when n approaches infinity of a constant, here it's a constant, a number without a variable, then the answer is that particular constant. So in this case, it's 7. Okay, according to the notes, it says if it approaches a particular value or a number value, that means it's a number, then that means the sequence converges. Okay? So now part C is just asking for the limit. The limit is 7. And then part D, it says explain why the sequence converges. Okay, so you write down sequence converges because limit exists. Oh, the limit is 7. Okay. In other words, na sequence na function ko okole ya landono bono ko sinila kutunga kole ya landono bono la bono le ya kina na number bitu kwena sinila kutunga the y value, it converges to that y number, y value. That's 7. So remember this. And this is how you're going to be doing the exercises for this lesson. Okay, all the best. I hope you will return me the working today. If you can't do the ones the previous lessons, please don't worry about it. Try and do the ones that I'm sending you today. Good night. All the best for today.